Good morning, 11th class. Today our topic is stoichiometry of chemical reactions. This is our last topic of first chapter. Okay, now first of all, stoichiometry of a chemical reaction. So what is the stoichiometry? So it is the quantitative relationship among the reactants and the product in a reaction. Okay, quantitative relationship. How? Okay, that one will I'll explain with the help of example. Now just see. Okay, you can take very general example, that is N2 plus H2, it gives ammonia. Generally this reaction is known as Haber's process. Nitrogen react with hydrogen, okay, it gives ammonia. Okay, then in case of stoichiometry, your first work is you have to balance it. That one is very important. Now just see, balance it. It's a 2, okay, 3. After balancing this, now just check in this nitrogen one molecule and check their ratio also, because it's a quantitative relationship among reactant and product. So if you know their ratio, okay, so whatever is the quantity, ratio is always same. Okay, and then so this one is one molecule react with 3 molecule of hydrogen, it gives 2 molecules of ammonia. This one is one thing. Now you can take it as mole also. 1 mole of nitrogen react with 3 moles of hydrogen and it gives 2 moles of ammonia. This one will help you in solving numerical. Now just see how. Okay, suppose this one is, because when you interrupt one thing, so all the reaction is interrupted, sub disturb hongi. So suppose this one, just like in maths, multiply all the numbers or molecules by Avogadro number. It's a 6.022 into 10 to the power 23. This one also, this one also. Now that one is converted into 1 mole, 3 mole and 2 mole. This shows what? That one is 1 mole of nitrogen react with 3 moles of hydrogen, okay, to give 2 moles of ammonia. Okay, now this one is converted into, okay, that one is in form of moles. So it means directly you can say, okay, in any reaction, whenever reaction is given, you have to balance it, and you have to check how many moles are reacting with each other to form a product, because their ratios are required. That is the meaning of quantitative relationship among reactants and product. Okay, convert it into mass also. Now just see. Okay, that one is taking molar masses into consideration. You know, nitrogen molar mass is 28. Now this is a quantitative relationship. Okay, that is mole, it's a 3 mole, so 3 into 2. Okay, because hydrogen is 2, it's a 6 gram, and in this case it's a 17. Ammonia, you can calculate their molar mass. Nitrogen 14 plus hydrogen 1 into 3, so 2 into 17, it's a 34 gram. So the interpretation of the coefficients as the number of moles in the is the basis of all the stoichiometric calculation. Okay, whatever is the this one coefficients are given, number of moles, that one is the basically main basis of stoichiometric calculation. Whenever you will solve numerical, okay, this one will help you directly. Okay, just see example. Calculate the amount of water in grams produced by combustion of 16 gram methane. Okay, so whatever, first of all, to solve this equation and all, your work is you can write equation. सबसे पहले equation लिख रहे हैं. Now it's a combustion reaction. Methane CH4 burn with oxygen. It always gives, whenever hydrocarbon burn, they always give CO2 plus H2O and lots of energy. Okay, the CO2 plus H2O, balance it. It's a 2 and 2 balanced reaction. Now just check your information. Okay, number of moles in CH4 is 1. This one is 2, this one is 1, and water is 2, but our consideration is with methane and second one is water, so we will take only these two things, बाकी से हमें कोई concern नहीं है. Now just see, 1 mole, okay, when react with oxygen it gives 2 moles of hydrogen. Now calculate their molar mass. Calculate it. Okay, that one is carbon 12 plus hydrogen is 1 into 4, it's a 16, and in case of H2O it's a 18. Multiply by 2 because it's a 2 mole. This one is 36 gram. Now from equation, अगर इसको ध्यान से देखो तो it is clear that 16 gram of methane produces 36 gram of water. जब इतना ग्राम मीथेन बर्न करेगा तो इतने ग्राम आपको क्या मिलेगा? दैट वन इज दैट वाटर, दैट इज 36 gram. Okay, तो simple. Your answer is that one is when this gram burn, the 36 gram of water is produced. So this one is your answer. Okay, you can take another example also. Now just see how many moles of CH4 are required to produce 22 gram of CO2 after combustion. Again, it's a methane combustion reaction, same CO2 plus H2O, balance it. Okay, now here methane and your concern is with CO2. So when 1 mole react with 2 mole of oxygen, it gives only 1 mole of, okay, CO2. So this is 1 mole. Okay, their masses in case of methane. Okay, how many moles? Actually here it's mole is required. So in this case gram is 44 gram. Okay, and here you have to calculate for 22. So you can use unitary method. 44 gram of CO2 are produced from 1 mole of CH4. Simple. From 1 mole of CH4, that one is 44 gram is produced. So what about 22 gram of CO2? How many moles are produced? Because you have to calculate moles, so no need to convert it into gram, otherwise. Okay, now so this one is 22 gram of CO2 are produced by burning CH4. Okay, that one is 1. 44 goes down, 22 goes up, and your answer is 0.5 mole. You can solve it directly here also. Okay, but we will not use direct method because this one is again, if you will follow normal formula and pattern, so if difficult question is there, so you can easily solve. Although this one is very easy, you can solve it easily. Okay, this one 0.5 mole. Okay, but this one is pattern, try to follow. Okay, thank you.